Here we go. Hi, everyone. Welcome to Spacelink's presentation on exploring Mars. I'm Jacqueline Campbell. Really nice of you to join us today. So Northbury Primary School joining us for embarking. I'm really, really lucky to have my colleague Divya and Persaud here. Divya is a research scientist. She works on a lot of things to do with Mars, rover, 3D imagery, but she's also a poet, an author, musician, composer, you name it, she's done it. And she's done lots of work with NASA, done various placements and internships there, and has a really good knowledge of lots to do with planetary science and space science. So Divya, I don't know if there's anything else you want to say about yourself?
I think you covered it.
Okay, brilliant. So today we're going to be talking about exploring the planet Mars. So I'm just going to start sharing a screen, and it's going to do some weird multiple screen stuff. And then we will go, we will go on to our presentation. There we go. And hopefully you should see our slides now. Can everyone see our slides? Yes. Brilliant. Okay. So we're going to start talking about exploring Mars. So Divya and I are both here working at the Mullard Space Science Laboratory on our doctorates. And we're going to talk to you a little bit about how we explore the planets. So the word planet comes from an ancient word meaning wanderer, because people from all over the world have seen in the past that although the stars seemed to stay where they were, the planets would move around, and we saw that they changed their position. So people started to give them names, and various different cultures gave them different names. But Mars is named after the god of war, the Roman god of war. And it's a red planet. We could see, even just by using our own eyes to see it, that it had a red color. So then we decided, how else could we look at it? So I wanted to ask you if you had any ideas of how can we explore planets? How can we here on Earth learn more about the planets other than just looking with our eyes?
Jackie?
Yeah?
You're hear you all the time.
Am I breaking up?
You're sort of going on and off, so we're not hearing everything you're saying.
Oh, I'm really sorry about that. How's it now?
That's fine. Yeah. That's
okay, maybe our microphone was, let's move it a little bit closer. Okay, yeah, so the planet Mars, I'll just repeat what I said. The planet Mars is something we could see with our eyes moving around, as well as the other big planets like Saturn and Jupiter, Venus, which is close by. And so we've known about Mars for a really long time. But I wanted to ask you, how else could we explore planets other than just looking at them with our own eyes? What other ways can we learn more about the planets?
We can send probes like the Curiosity that is at Mars at this minute, I think.
Yeah, that's a brilliant answer. Any other ideas?
We could send satellites like the one that was supposed to go around, I think it was Saturn.
Okay, that's absolutely right. Another really good answer. Even longer ago, a long time ago, there was a way that we could look from here. So any ideas on how we might look without having to send off spaceships? How might we learn more from here on Earth?
You can use telescopes.
Yeah, perfect. Brilliant answer. So the first telescope that we know of was in 1608. There's some record of a patent being put in for somebody that invented a telescope. But it's likely that other people were using glass and lenses maybe earlier to look at things in the distance. But we started to be able to see the planets. And here on the right, you can see a really beautiful picture taken with an Earth-based telescope by a photographer called Damien Peach. And if you like pictures of planets, then I encourage you to look at Damien Peach's website, and you'll see all sorts of beautiful images of all different planets that he takes with the telescope just from here on Earth. So that's pretty cool. Divya, do you want to talk a little bit about some of the things we can see on the planet here in this picture?
So actually, I'm gonna ask you what is interesting that you can point out in this picture of Mars.
So there's some blue marks on Mars.
How about
speak up.
There's some blue spots on Mars.
Anything else? The colors or the shapes?
There's also something that looks like a mini North Pole, mini South Pole.
Yeah. So one cool thing we can see here is we can see the South Pole, which is actually what Jacqueline studies. So that little white circle at the bottom is the South Pole, and so that's carbon dioxide ice. We can also see these big red patches and these darker sort of grayish blue patches, and so those are different types of rock. So it's, we can start to get an idea of what is there if we understand what different colored rocks are here on Earth. And also at the sort of left and right side, I think you can see a bit of the atmosphere as well. So those are clouds at the equator that form in, I believe, the spring and summer. So Mars has its own weather patterns, just like Earth. It has clouds. It has the poles. The polar ice caps change size. Sometimes there's a bit of carbon dioxide snow. So we can actually learn a lot from just telescope images.
That's really cool. And also Divya's background is geology, so she knows a lot about our planet Earth as well. And when you're studying planets really far away and you don't know much about them, one of the things you can do is compare the processes and evidence you see here on Earth, where we can get close-up ideas and compare it to what we see on other planets. So Mars is quite similar to Earth in many ways, as Divya described, all these weather patterns and ice caps and a solid surface, unlike some of the big gas giant planets like Jupiter and Saturn. So moving on from telescopes. Actually, this is a really interesting picture. These are some sketches drawn in the year 1659 by a scientist called Christian Huygens. And again, going back to some of the things we can see in that picture, even back then, he was noticing some of these dark changing patches. And he also noticed that sometimes Mars had features on it and sometimes it seemed quite blank. And we're going to show you a little bit more about that later. So flybys. Can anyone tell us what a flyby is?
I think a flyby is when a thing that would like take pictures of the planet. So basically, it goes around the planet and then it goes out to space, and sometimes it goes back to Earth. So it just flies by the planet and goes back to Earth, I think.
That's perfect. That's a brilliant answer. So exactly like it sounds, like a flyby, rather than dripping into orbit and going around and around sort of permanently, it will go past. And this is a really good way to look at many different objects. So something like the Voyager spacecraft or the Pioneer spacecraft that went out towards the outer solar system, this would take pictures of planets on its way past. So flybys are a really good way to get a look at planet, and especially lots of different planets. But if you really want to look at a planet in detail, you might want to stop and stay a while. So this is Mariner 4, which was the first flyby mission to Mars. So that was in 1964. So it's not very long ago. If you consider like hundreds of years, we've had these telescope images and people studying the movements of Mars just by looking with their eyes. But it wasn't until the 60s that we started to get some images like this. And this shows a little bit more detail of what you can see with some of those telescope images. And again, you can see that nice bright ice cap there. And this is from Mariner 7 in 1969. So orbiters. This one in this picture is Mars Reconnaissance Orbiter. So that's got loads of different instruments on it, and that takes lovely pictures of the surface of Mars. And here's an example of the Viking Orbiter pictures that we got in 1975. So you can see, you can start to get a lot more detailed imagery if you can stop and stay a while and go around and round. This one is a mosaic that's been made up and made to look a bit nicer. But some of the more modern images... Oh, sorry, go ahead, Divya.
Actually, I just wanted to ask, so what can we see in this picture that might look familiar to us on Earth? What sort of... So the trouble with satellite images is we don't often look at our own planet with them. But as geologists, we have to start thinking, okay, if I was on the ground and I was seeing these huge features, what would they look like? So can anyone sort of take a guess? And maybe, because there are lots of interesting things going on here.
So I can see a few craters around.
Mm-hmm.
Also, there's a canyon near the top.
Yeah. So that's Valles Marineris. I think it's considered the biggest canyon in the solar system. So it's kilometers and kilometers wide. It's very deep. Yeah, you can see it from very far away from Mars. Anything else? Maybe in the upper left.
I can see some like crack things.
Mm-hmm.
I think the cracks are like where rivers used to be.
Yeah.
Yeah, this is really good. You can see there's
lots.
Yeah, lots here. So this is some of the evidence that maybe there used to be lots of liquid water on Mars. You see these sort of river channels, canyons, gullies.
Mm-hmm.
So there's lots of evidence that there were similar processes on Mars, even though we don't see lots of liquid water or rain on the surface today. We can see evidence that it was there. And up in this top left corner, can you see those two spots there on the top left?
The really dark ones. Yeah.
Any idea what they might be?
Craters?
Well, they do have craters in them, but they're actually big volcanoes. that just as we have, say, the volcanoes in Hawaii, they'd be very similar to those, except huge. So they were so big that when they erupted, they just completely collapsed. And so there's sort of these big mounds left on Mars with craters in them. But we know that there are huge, huge volcanic eruptions on Mars at some time.
Yeah, so we think that there's maybe not much going on Mars in terms of volcanic activity, but actually we're going to talk a little bit later about how we can see if there is still some sort of activity and processes going on Mars. We don't see lava flows like we do still today in Hawaii and other volcanoes on Earth, but there is other ways to see if there's things going on under the surface. So this is a beautiful picture. This is from the Mars Reconnaissance Orbiter camera called Highrise, which takes these beautiful images in really high resolution. Anyone want to guess what this might be a picture of?
I think the blue wavy things are water.
Ah, wow. Brilliant. That's really good. This is frozen water. So this is water ice. This is from the North Pole. So in the North Pole, we have these series of layered deposits of water ice that build up and up and over time, and they get dust trapped in between. And this is a really nice detailed image of those North Polar layered water deposits. So yeah, fantastic. Really, really good answer there. And you can see, I mean, the colors, they change the colors a little bit on some of these images so that we can see better what's going on. But there really are some beautiful images. And if you want to see more like this, you can look up the Highrise website and just see just loads and loads, thousands of pictures of the surface of Mars in this really beautiful high detail. So on to landers. Landers are cool because now, rather than just taking pictures, we can get down and do some experiments. Do you guys want to talk about what kind of things might you want to look at? If you could land on the surface, what kind of experiments could you do there?
Well, if I wanted to land like on Mars, one experiment I would do is like I would try and see if you can make plants grow, like plant a seed and water it and see if it would grow on Mars.
That's brilliant. So these sorts of biological tests and things, see how life might work there. It's interesting you say that actually. The one of the first landers, the Viking lander, that did some, I think we've got a picture of that next actually. Yes, so this is from Viking I lander in 1975, and there were two identical landers that went down. And some of the tests they did were biological tests to see if there was anything already there. So they would take soil samples with a little robotic arm, bring the sample to the lander, and then do experiments on it to see if they could find any biological activity, if there was evidence of bacteria trying to use up energy. And there were a few sort of inconclusive results where they weren't really sure. It might have been something that was just a chemical reaction. And there's still a little bit of controversy about that today. I think mostly people, what would you say, Divya?
I think people want it to have been a positive detection, but no one can say.
Yeah.
I think we just say, well, we need to send more.
Yes.
Send more.
So the thing with science is often you think you've answered a question, but you've actually made 10 more questions, which is why we need more scientists to do more science to find things out. So you were talking about maybe trying to plant something. And interestingly, one of the things we are very careful about is protecting planets from bringing things there that might contaminate the surface and bring life from Earth. So when we make these instruments and machines to go to space, we have to clean them really carefully in a clean room where they expose them to really high temperatures and radiation and sterilize them, because they want to be careful about bringing any little bacteria or bugs there that might contaminate the surface and ruin the results of your experiments. But I think in the future, it would be impossible to have human exploration on Mars without some sort of growing things and making sure you could grow food. So I think in the future, they probably will have maybe like greenhouses or protected environments where they can grow things for the people who are living there. So that's definitely something we'll see in the future. Okay, Pathfinder and Sojourner. So moving on from landers, the next step is roving around. So rovers are pretty cool. Divya, do you want to tell us what are some of the advantages of a rover over a lander?
Right, yeah. So landers are really nice because you can land in a spot and then you can study it for years. Hopefully years. Sometimes landers only last a few months, but you get to really understand that one spot, which is amazing because it's another planet. But the cool thing with rovers is that you can move, right? So say you see something really interesting close by to where you've landed, you can actually travel and see if it's appearing in another spot. And so as a geologist, we can actually reconstruct the timeline of events. So if we think there's a rock close by that suggests that there was water there, and we drive a few miles away and we're still seeing those rocks along the whole way, we can say, okay, there was water over this whole area. And different types of rocks can tell us whether that water was warm, whether it was salty, whether there were important chemical reactions that are useful for life. So getting to travel around, I mean, we get a broader perspective of what's happening on Mars, which is really exciting. But we could also see, if something interesting is happening, how far it's happening, the general area, and then we can actually really think, okay, maybe there was a lake that was this wide over this area and this deep, and that's very exciting. So you get more of like a three-dimensional picture. Mm-hmm. And then, of course, you also get actual three-dimensional pictures, but I think we'll talk about that later.
And what about how does this rover work then? Is somebody controlling it?
Yeah, so, of course, rovers can't operate on their own. I mean, we could program a rover to do that, but it's really dangerous because Mars is so far away. There is about an 8-minute delay between any communication between Earth and the rover, which means the rover could fall down a canyon and we wouldn't find out until 8 minutes later. So there's no real way that we could save it. So the safest way to control the rovers is actually to send communications to the rover to drive a certain amount, the rover to tell us that it sees a sharp rock in its way, or whether it thinks that the area is clear, waiting for that message to come back, and then telling it, okay, proceed, let's go ahead, let's pick this direction, let's pick this other direction. So there are teams of people on Earth. So at NASA, they would sit in the rover control center, and every single day they would get the information from the rover, figure out what they want to do, and then send the commands back up. But the problem there is that Mars day is actually 25 hours, and that doesn't seem that different from an Earth day. But if the rover wakes up with the sun, because, and we'll talk about it, if the rover is using solar panels for energy, it'll wake up at dawn and go to sleep at dusk. And that's Mars dawn and Mars dusk, not Earth dawn. So every single day, there's 1 hour later you have to get up to receive the information from the rover. So for the first few months of rover mission, people live in Mars time. So they actually live on 25-hour days, and which is very tiring because after a long time, you're eventually waking up at night and you're going to bed in the morning, and it's quite a lot of work. So there are tons of people who do this, and they switch off when they're tired and try to understand what the rover is seeing and what it's saying about its environment so that we can actually keep it safe and also do really cool science.
That's awesome. Thank you, Divya. Here, we've got some pictures here of how this landed. So as these instruments and missions get more complex, they get heavier because the more you want to put on them, the more it weighs. And so you have to think about how you can safely get down to the surface. The early landers, they just use rocket boosters to sort of steady themselves and float down. But here we see something they developed for the Pathfinder mission. The mission would slow itself down just by aero braking using the atmosphere when it first came in and letting a parachute out. But then it was still too heavy to hit the floor safely just using rocket boosters. So here they developed this airbag system. And in that middle picture, you can see these big sort of bouncy inflatable balls that were wrapped around the mission instruments. And then it bounced around, landed on the floor, and then opened up. And in the bottom, you can see where it's all opened up and then let out its little rover there on the top right. Which was able to rove around on the surface. This thing's tiny. It's really small. It's kind of not much bigger than a remote-controlled car. And it sort of poodled around on the surface and had a look at things. But it was a real pathfinder in its name and nature in working out how we might do further rover missions to Mars. So somebody mentioned earlier Curiosity. So this is the Curiosity rover. Now this, I'm totally wrong. This is Mars Exploration Rover's mission, which was at 2 rovers that were identical rovers, twins really, called Spirit and Opportunity. And they were sent up in 2004. And I would say you could say this is maybe one of the most successful missions of all time.
Yeah, I think so.
Yeah. So Spirit, the rover, died a little while ago. But Opportunity, is there any more news on Opportunity? Yeah, it went to sleep, right?
So with Spirit died in sort of 2007. So yeah. I mean, that was considered successful, that mission. I think they just hoped it would run for a year, I think. Opportunity's been going, but got caught in a dust storm in July, I want to say. So I mentioned solar panels before, and we'll show a picture. So Spirit and Opportunity would get their power from the sun, and so Spirit, unfortunately, it didn't die. But what happened was there was a big dust storm. There was all this sands that got deposited on these the solar panels, which you can see are just flat.
There we go.
There you go. So I think it must be Spirit. Yeah. So you have sand covering it, which means it can't get energy from the sun anymore. So Spirit is currently in sleep mode. We don't know whether we'll ever contact it again, but it's asleep somewhere. Opportunity got caught in a very big dust storm in July that covered the whole planet. So the sort of difficulty with Mars, we don't know how to predict the dust storms, but they pick up very quickly because the dust is so small. And so we get these huge global sandstorms. So we didn't know how long Opportunity would be in the sandstorm. We didn't know whether the winds would eventually blow the sand off. So we put Opportunity in sort of emergency mode to wait out the storm. And so every sort of few days, I think they send a message to Opportunity. I think originally it was every day, sending a message to Opportunity and seeing if we could hear back. And it's been a few months and we still haven't really heard back, but I think NASA just got the go-to to do it for a few more months. And then after that, we'll call it mission success. But otherwise, Opportunity has been running for 14 years, which is incredible. And
this also goes back to those drawings I showed you by Christian Huygens earlier. So sometimes people notice that Mars had lots of features. Other times it looked pretty blank. And this was probably the result of these global dust storms that were obscuring any feature on the surface. And you just had this planet-wide dusty storm that meant that you couldn't see through the atmosphere to see those surface features anymore. And you can see how thick this dust is. You can barely see those solar panels compared to the floor. It's just covered in so much dust. I know that when they were designing these, they were looking at ways to try and clean them and maybe have windscreen wipers or little like rolling sort of cling film bits that moved off and cleared it. But they didn't really find anything that works so well. And usually they try to position it in a way that after the dust storm is over, it will be angled so the wind can blow the dust off and then it can come back to life. So I guess we'll just wait and see if Opportunity manages to clean itself up and get back together and start sending back more data. So here's some pictures that were taken by the rovers, the MER rovers. And this top one, you can see this lovely, nice panorama image. And you can see it looks a bit like a lot of deserts on Earth. It looks like some of the deserts you might get in North America or Africa, where you get these sandy formations and then larger craggy rocks. And at the bottom here is quite interesting because when things go wrong, obviously that's bad news for a mission, but sometimes you can get a positive result. So at the bottom here was where Spirit's wheel got stuck. One of its wheels stopped turning and it was dragging it along. And normally this would be bad because it slows the rover down. It can't maneuver it so well. But this actually dragged up the subsurface underneath. And you can see this white material here, which is some silicate-rich soil that they found underneath that they didn't know was there. And this only happened because something broke. And then the rover was able to turn around and take some measurements and see what this stuff was under the surface. But sometimes you can turn a positive into a negative in a mission, and you have to be prepared to do that because you can't send a mechanic out to go and repair it. So you just have to do your best. So what have we got here, Divya?
Yeah, so this is from Spirit and Opportunity. So in the upper left, can anyone guess what that is? It's a weird looking rock. It's kind of shiny. Anyone? So I'm going to say that that rock actually came from somewhere else in space. That is a meteorite. So it landed on Mars. It survives, probably impacting at probably hundreds and hundreds of miles per hour. And it's actually made mostly of iron and nickel. So it's really shiny and there's a bit of dust on it. And the rover was able to actually see that. And we know that that's a meteorite because we get similar meteorites on Earth. And it looked nothing like the rocks that we see on Mars. The middle picture, can anyone comment on it? What's cool about this?
If I were to guess it could be a pole. If I were to guess it could be a pole, like the North Pole or South Pole.
Okay. Yeah. These are actually little minerals that are called hematite. And so they're little iron-rich minerals. And what's really interesting about these is that you only get them when there's been water around. So this is evidence that there might have been standing water on the surface that was sitting there for a long time. And we see these minerals form on Earth, and we know that you need to have the soil sitting in water for quite a long time for these to form. So this is, although there's no water there now, seeing little minerals like these, which they've nicknamed them blueberries, I think, because they look like little blueberries. And we found those all over the place, right? They were just mixed around everywhere. So it was evidence of widespread standing water in the history of Mars. So that's pretty cool.
And then in the upper right, so that's actually a bunch of rover images, and they've sort of edited the rover back into it. But I believe that's Victoria crater. So that's a big impact crater on Mars. And something cool we can do is when there's an impact crater, all this rock has been sort of excavated. It's been thrown up into the air. And in the sides of the crater, we can see the rock record. So that means we see all these layers in the rock. And as you go down, you're actually going back in time. So one thing Opportunity Rover did was actually study these different layers. And so you can see it. I think that's the rim of Victoria crater, looking at all these different layers of rocks. And so those rocks actually told us that there was a lot of big dunes in that area. So very high-speed winds going different directions and depositing sand. And then in the bottom picture, I think that's a 360 panorama. So you're actually seeing a lot of different types of rocks. You're seeing those like platey sort of sandstones, and then a lot of dark sediment. So that's sort of showing sort of, I guess, a different types of history, I guess.
So we see a lot of the rocks that we see on Mars look a lot like environments we see on Earth, and many different types of environments. So there's obviously been lots of different processes. So Divya mentioned the wind, that you can see how it erodes things out, and we see examples of that in deserts like in Colorado and Utah. You see all these wind-blown formations. They have a special name for that. It's aeolian processes. So that means when wind forms the landscape. Then you have rivers that make these riverbeds, and these are called fluvial processes. You have another one for lakes, and that's lacustrine. And so there's all these names. When you do geology, you have to kind of learn a new language almost to kind of understand all these processes. But they're all very familiar things. They're things we all know and see in our everyday life. And especially if you get the chance to go out a little bit into the forest or into nature, and you can go and have a look at these rocks and try and guess when you go down to the beach, is this a sharp rock? Is this a round rock? What's happened to it? Has it been in water for a long time? And there's loads of information online. If you're interested in finding out more about geology, you'll be surprised in your own back garden. You can find out lots of different things about rocks and what they're made of. So I definitely encourage you to go outside and touch rocks, because we wish we could go and touch rocks on Mars, but we have to send robots to do it for us. Just at the bottom here is just a little note about Opportunity. It's done more than 45 kilometers, which doesn't sound like a huge amount over all those years, but for a Mars rover, that's a huge amount of distance it's covered. And it went up the steepest slope that any rover has and to the highest elevation that any rover has. So it's a bit of a record breaker, and we hope it comes back to life and we can speak to it again. And what have we got here, Divya?
So on the left, that's the wheel from the Sojourner rover. So that was one of the little test rovers. The middle wheel is from the Mars Exploration Rovers, so Spirit and Opportunity. And then on the right, that is one of Curiosity Rover's wheels. You can see over time, these things have gotten bigger and bigger and also tougher, which is really cool. I mean, you can kind of see Sojourner was a bit like a toy car. And Curiosity is about the size of a pretty big car, I think. Not like a lorry.
Yeah, it's really big and it's really heavy. I think it's the heaviest thing they've sent to Mars. It's like 1,000 kilograms.
Yeah.
So this is huge. You can see how they're getting bigger. But you'll notice they've all got similar things like we'd have on tires on Earth, that you want to make sure you've got grip and tread like you have on any tire. And obviously these are things that they have to test. So, Divya, you've been involved in some rover testing stuff recently, and what kind of things do they do to make sure rovers are going to survive on Mars?
Yeah, so one thing they did with Sojourner all the way through Curiosity, so there's something called the Mars Yard at the NASA Jet Propulsion Laboratory, where they actually test out all these different types of wheels. And so they have a big yard. It's covered in sand, big rocks, types of rocks we would see on Mars. And they just put out big models of the rovers. So essentially they make 2 or 3 of these rovers. and just drive them around and see what wheels work, what don't. You know, a lot of times different types of wheels unexpectedly get a lot of sand stuck in them. We don't know unless we try them. So we actually just make multiple rover systems and drive them around.
Yeah, so people who are working on these missions, they're not just planetary scientists or physicists. You need engineers and people that understand how things work. So there's a lot of different disciplines needed to make one of these missions work. So that's pretty cool. So that big one on the right, as Divya said, it shows you how big these rovers are getting. And this is a picture of Curiosity. So this is that great big rover that's up there now. It's been up there since 2012. And on the left there is just a diagram of all the different instruments. And it's called Mars Science Laboratory. And it really is a laboratory. It has so many different things on it. I think it's got something like 17 cameras, as well as loads of different chemical labs and analyzers. It's got a little laser that it can like fire at rocks and then measure the vapor that comes off of it. Does anyone know how this is powered? Can anyone have a guess at how this is powered? We know that Opportunity and Spirit had these big solar panels. What about Curiosity? Say that again? What was that? I think that's nuclear. Did someone say nuclear?
Yes.
Yes, brilliant, fantastic. So yeah, this is on the top right of that diagram, you can see RTG, and this is the abbreviation for, what is it, radio? I can't remember what it stands for now, but it's this is a nuclear package there that is, you wouldn't want to go near it and sit near it, and it's pretty warm. In fact, they were a little bit worried about how it might affect things on the surface. If there were bacteria, they didn't want to get the nuclear stuff too close to it, but they realized that it had more benefits than it did risks. So this means that Curiosity, unlike Spirit and Opportunity, it doesn't have to worry about dust storms covering up its solar panels. It's got enough power to run for a really long time. And also this is the kind of thing they use for things like Voyager, where they're going to send them out into the solar system because they're too far away from the sun to get any energy from that. So things that are going to be going to environments where there's not much sunlight, they really benefit from this, but they're heavy, so that's a problem as well. So it's whenever they do a mission, they have to weigh up the sort of risks and benefits of whatever they choose to see what's going to work best for any given instrument. Yes.
Yeah. So one cool thing about this picture is that sometimes Curiosity takes selfies. So in this picture, it has its arm sticking out. You can't really see it. And it's taking a selfie because it's so big. We have all these cameras on it to also check that it's working because it has so many different parts. And so these selfies actually help us understand if there's any dust getting in the way of instruments, if anything is broken, then we can actually know. But it's also nice that we get a little shot of Curiosity imaging itself.
Yeah. Was Curiosity the one that sing Happy Birthday to itself?
It was once. Yeah.
Oh, just once.
Just the one time, yeah. So it was programmed to sing Happy Birthday a year after it landed, I think, in 2013.
Yeah. Lonely birthday for Curiosity. Have the rovers ever met, or are they really far apart?
No, they're really far apart. Although I think Mars 2020 might end up close to where Sojourner was or something. But because we can only send so many rovers to Mars, they're expensive, they take a long time to develop. It's better for science for us to put them in different sorts of places on Mars.
So no rover parties?
No rover parties.
Oh, that's sad. How did it get to the surface, Divya?
So in the past, we had the parachutes and the airbags. Curiosity was just too big to bounce around in some airbags. That made a lot of people nervous. They actually invented this new thing called a sky crane. So the sky crane is actually at the top of the picture. So Curiosity is actually like nested in it. There was a heat shield. It was hurtling towards Mars. It ejected the heat shield and then started sort of firing its thrusters to slow down really, really rapidly. So this thing is going super fast. In about 7 minutes from entry of the atmosphere to the ground. So they call it the 7 minutes of terror. And of course, it takes 8 minutes for any of this information to get back to Earth. So truly terrifying. And you only get these signals once in a while saying, okay, the heat shield is off, the thrusters are firing. So it's slowing down really fast, and then it starts to eject Curiosity. So on this cable, it starts to lower very, very gently, and it's still thrusting, so it's still slowing down. It's moving pretty quickly. And Curiosity is in a sort of safe configuration where it can't get hurt. And so it needs to slow down enough that it's no longer accelerating, it's moving pretty slowly, And then finally, close to the end, it ejects Curiosity, and then the Sky Crane flings itself out of its way. So there's no chance of it hitting the rover, which is pretty cool. So we actually have high-rise pictures of where the Sky Crane like flung itself. And then Curiosity has been let down, hopefully gently on the surface with everything intact, and then it has to unfold itself.
Wow.
So all in 7 minutes from the top of the atmosphere to the ground.
And that had never been done before.
It never been done before. And I think many people won awards for just the human invention. We'd never done it on Earth. It was terrifying. So
that's scary.
I think they're still going to use this technology in the future because it was just brilliant.
Yeah, it's fantastic. It's really clever. So here's a nice image. This is taken by Curiosity, and you can see how familiar this looks if you've ever seen pictures of any of these rocky deserts that we've got all over Earth. It's really similar. There's no doubt that some of the processes that have happened on Mars are really similar to processes that we're still seeing happen today. So that's a really good way that scientists can try to predict what's going to happen by looking at deserts in various stages of their evolution over time and try to work out how that relates to the things we're seeing on Mars. And although those orbital images are beautiful, what we really need is to be able to get up close and see these things. So there's just no substitute for landing on the surface and being able to move around. And unlike landers where you have to plan many years in advance one spot and stay there, the rover can change its path, and we can decide where to send it based on the evidence we found. So it's a lot more flexible in terms of your mission plan. So that's pretty cool. Here, what have we got here, Divya?
So even though we've tested these wheels on rocks and stuff, that you can't always predict the Mars environment. So Curiosity actually went through some wheel damage, which was pretty sad. So I think it got stuck for a while, and then due to some design failures, rocks got stuck in, sort of ripping through the material, and we see what's in this image, which means that we have to be really, really careful how we drive Curiosity now to make sure that no more damage happens and that it doesn't get stuck. So even though we do all these like really brilliant, cool things, we run into trouble.
Yeah, and the thing is, obviously, you'd like to just be able to send big, heavy-duty, chunky tires that could withstand anything like we have on trucks down here, but they're too heavy. So these wheels are aluminium. They're really lightweight. They're really strong, but they obviously weren't prepared for quite how much they'd be put through on the Mars surface. I think that the new NASA rover is going to have aluminium wheels that are slightly thicker and a better design, and the ESA rover, ExoMars, is going to have titanium wheels, which are super strong. So hopefully we'll see how those rovers go and see if they can stand up a little bit better than these ones did. So here we go. So we've got the two new rovers going up here. So they're both going up the same time, roughly, right?
Yeah, pretty much. They're both in 2020. So yeah, the top one is the NASA mission, Mars 2020. So that's just an illustration of what it will be. So big, very big. So you're actually seeing 6 wheels this time instead of 4. There's a drill at the front, if you see it on the long arm, and then a whole suite of instruments like Curiosity. And then the bottom is actually, I think that's a model of, or is that an illustration? So that's ExoMars 2020. It's a bit of a different design, but still 6 wheels. It has solar panels, so it's not going to be nuclear. The drill is that big black thing in the front, so they're both going to try to look under the surface to see what else we can learn that we can't just see from the top layer of dust on Mars. And then, of course, the long neck with PanCam at the top. So PanCam is actually being built here where Jacqueline and I work.
Yeah, so that's pretty cool. So we've got two for the price of one.
Well, two for the price of 2.
Yeah, they're very expensive. And one of the reasons, actually, that the Spirit and Opportunity rovers sent twin missions is because when you design these missions, you spend a lot of money on the development, the planning, or the instrument design, and that's very expensive. So if you can build 2, then you've saved money in a way. Although it's more expensive to build the second rover, you don't have to do a separate set of science and evaluation and engineering. That's all been done. And this is applied to lots of things. So we have lots of little missions called CubeSats, and it's like, why send 1 when you could send 10 or 20? And so the more you can send, it's like buying things in bulk. It's cheaper to buy a 6-pack of something than just 1. So they can spend all the money on the development and then just only have to spend the money on building it, which saves money in the long run. These missions are very expensive, and there's just 1 of these each. But I think that the Spirit and Opportunity mission was a great demonstration of how it works to send double of something to 2 different areas and take advantage of all that science and development that happened.
A lot of the scientists on ExoMars are working with scientists on Mars 2020. So there's a lot of collaboration going on. A lot of people from Curiosity are also working on both. So it's never a competition. Everyone's working together, and I think it'll be really cool to have them both there, doing different things.
Yeah, so we should see a lot of data coming back from these over the next, from 2020 when they sent off, and then they land over the next, hopefully, several years of operation. And then even if they stop working after a few years, that data will be useful for many years to come. We're still analysing data from missions that were sent in the 60s and 70s. So just because a mission's over, there's still plenty that people can do with the data. So it will be people your age now that are working on this data and designing the next generation of rovers. Here we go. So this is a new mission. Has anybody been following the news? Does anyone know about any Mars missions that have been in the news recently?
There's a new mission called Insight.
Fantastic, brilliant. Does anyone know what Insight's there to do?
I think it's going to be measuring Mars quakes, which are basically earthquakes on Mars.
Oh, amazing. Perfect answer. Really, really good knowledge there. So, yes, so as you said, earthquakes on Mars are called Mars quakes. And we talked a little bit earlier about those volcanoes we could see in the picture. We don't see any current evidence of like volcanic eruptions or major Earth or Mars quakes on Mars, but that doesn't mean things aren't going on. So in the past, we've only ever sent instruments called seismometers, which look for this sort of earthquake-like activity. We've only ever put them on the moon. And they did find moonquakes on the moon. And the moon is way deader than Mars in terms of like activity and changes on the surface. And they still found some evidence that there was a little bit of sort of maybe cooling and contracting and moving and these little moonquakes happening inside the moon. So this will be really interesting because it's got this instrument on the surface that looks for any vibrations or movements, and then it also has this little tool that burrows down deep and looks at how the heat moves in the subsurface. So this instrument really wants to find out what's happening in the interior of Mars. We've seen the rovers have a look at the surface, but we want to know what's going on inside.
And so one cool thing about seismometers, so if we can actually measure, say on Earth, we do this a lot on Earth. If we're measuring an earthquake, those are actually like huge, essentially sound waves that are moving through the Earth. And if we can listen to how they sort of bounce around inside the Earth and against each other, we can actually figure out what's inside, how deep, that sort of thing. So if we're measuring Mars quakes and we listen very carefully, we can actually understand the whole structure of the interior of Mars, which is really unknown. So we can understand how much rock there is, if there's still magma inside, and that will help us understand Mars. But one cool thing with the seismometer, though, so we had to make it really, really sensitive. And forgive my American geography, but so they were building the seismometer in Colorado, so that's close to the west coast of America. And they said that the seismometer, when they were doing testing, was picking up waves breaking on the East Coast, like close to New York. So that's maybe like 1,000 miles? 1,000 miles away. It was picking up just waves breaking on the beach.
That's incredible. Yeah, so that's sensitivity. And this is another thing that you have to be careful with such sensitive instruments. You've got to send them through a rocket launch to get them off of Earth. So if you've got something so sensitive, it can tell when waves are hitting the shore on the East Coast, when it's on the West Coast of the United States. How do you protect that when it's got to go through a launch and like be jostled around and vibrating as this rocket goes up? And so one of the things we do at our laboratory and at other laboratories across the Earth, they do vibration testing, making sure that these things can be protected and that any sensitive parts are switched off so they don't get overloaded, so that you can send it safely through the trauma of going up into space and then landing on the surface or bouncing around on an airbag or being lowered from a sky crane, and then still turn it on and it still be sensitive enough to take these measurements. Yeah, so it's pretty incredible. So finally, the future. Do you guys have any thoughts on sending people to Mars? Do you think it will happen? Do you think it's a good thing, bad thing? What are your thoughts about human missions to Mars?
I think it's because essentially they can pollute the environment like we're doing to Earth right now, and then that might affect Mars in the future.
Okay, so you think maybe we could move there if the conditions are bad on Earth, maybe we could move to Mars and live there. Yeah. Well, I think it's really important for us to take care of Earth here, because if we can't take care of Earth, what are we going to do to Mars if we move there?
Yeah.
So I think it's important for us. I mean, I think the future of humanity, I mean, eventually we know that in a few billion years, maybe Earth won't be here anymore. So if human species continues, presumably that will be living in other solar systems or on other planets. But I think we need to have a real careful think about how we treat our environment and how we treat our planet. And this goes back to what we were saying about planetary protection. If we send people to Mars and we want to grow plants, like one of you mentioned earlier, we're going to be messing with the Martian environment. Are there any Martians already there? Are there any bacteria? Do we owe them protection from us going there and destroying their environment? And obviously this has applications to not just Mars, but if we find any life on other moons or planets anywhere, and we need to think about the implications of how we treat them. And at the moment, we don't even really do that here on Earth. So that's something I think that there needs to be people involved in this, not just like we said, in engineering and physics. There needs to be people who understand ethics and philosophy and politics and finances and environment. And you need people from all sorts of different backgrounds to really make this work. Not to mention, how are we going to entertain these people? We need music and art and literature and fun and stuff, and medical doctors, all the things you need to make society run well. You're going to need that too. Do you have any thoughts on that, Divya?
Well, I think there's sort of a movement in planetary science, in planetary protection. So the people who sort of do planetary protection, I've met a team of them, and they said, it consists of religious leaders and philosophers and artists, because who are we as scientists to say, okay, we understand what people need and also whether what we're doing is right, because we're just one type of person, right? We need everybody, and we need these people from different countries. We need these people from different parts of society, different parts of even just one country or one city. You can't just have a few scientists from a single university saying, oh, I think it's ethical if we go kill some bacteria on Mars. It's a human project, and I think we focus on that because it's complicated. I mean, I want to go to Mars. I would love to go to Mars, but I also got to think, it's also really polluted down my street. What can I do to help out both situations?
Yeah, and it's not a zero-sum game, right?
There's no right or wrong answer.
Yeah.
I think that's also kind of the fun of doing anything with space. You're always thinking about the big questions.
Yeah, big questions and what it means. Our history of being pioneers sometimes causes real problems and damage to the people already there or to the environments already there. And so I think that that's something that we all need to think about, and that's why it's important for everyone, I think, to take an interest in this, because it affects everyone. So regardless of whether you want to be a scientist, there's space science is going to be something that is going to be big in humanity's future, and something we need to think about. So I think that's the end of our presentation. So I'm going to just stop sharing my screen. Sorry, it's going to do some weird infinite screens here. Stop screen sharing. Yeah, I know, it's a bit scary. There we go. Okay, so we're back in the room. Do you have any questions you'd like to ask Divya or me?
If a rover completed its mission, would it stay on Mars, or would it come back to Earth?
Yeah, so they actually just stay on Mars. So the way rover missions work is we have sort of called a nominal mission, or the primary mission. So we set out a certain number of objectives, like drill a hole, or investigate these minerals, or just look around the area and perform these experiments with all the instruments. And then we make a timeline and say, okay, let's say that would take about a year. And so that's how the mission's structured. And then after that, we can say, okay, if it survives, let's go into the extended mission. And that has a bunch of other science questions. They usually bring on different people from usually different space agencies, different countries, universities, to come up with new questions and new things to investigate. So there's after the primary nominal mission, which is actually usually 1 to 2 years, these rovers tend to survive. So we usually have the extend mission. So there currently is no way, we've never been able to return something from Mars, and that's something that's sort of in the works, but it's really, really difficult.
They've done it for the moon, right? So we've had a couple of sample return missions. Russian space agencies have brought stuff back from the moon. So, but the moon is, compared to Mars, the moon is like next door. It's still, I'm not saying it's not difficult to go to the moon or bring things back from the moon, but it's much, much closer to Mars. Yeah,
it's closer. There's lower gravity and there's no atmosphere. So the thing with Mars is that it's far away. There's more gravity than the moon, and then there's an atmosphere, which means like launching something from Mars to get back here would take a lot of power, which means we need to send sort of a rocket with the rover, and then I would have to come back. So we've never really done that. We've never found it to be worth it. But so Mars 2020 though has sort of a little cache where it will drill rocks, or it'll select rocks from its area, about I think 100 grams, and it'll keep it for a future mission to come do a sample return. But we don't have the technology yet. So right now they just stay there until they run out of power.
Any other questions? I'm really sorry. Can you say that again? We couldn't quite catch that.
Are the rocks
Are the rocks on Mars really hard, or do they break easily?
Oh, that's a great question.
I think it's a mix.
It's a mix. I mean, much like Earth, it's a bit of a mix. And unlike Earth, here we go around with hammers. If you ever meet a geologist, they will have a hammer. They love hitting things with hammers. I mean, how many things have you smashed with hammers? A lot of things. So if you want to do, if you like hammers, do geology. You will get to go around and like hit things with rocks and scrape things. And so we actually have a way of saying how hard things are. So we have a special scale in geology called the Mohs hardness scale. And it runs from, as it talc is the lowest. So like this is really soft and you can push your fingernail into it easily. And then it goes all the way up to number 10, which is diamond. So diamond is the hardest natural substance we know. And so we rate rocks on this scale by comparing them to a known series of minerals that have different hardnesses. And on Mars, they have a range of different rocks. Some of them will be crumbly, like you could just crumble them with your hand. And then others, like that meteorite, for example, that will be like really hard metallic rock that it would be very difficult to break and very heavy and dense. So you have a range of different rocks, much like Earth. And again, that can tell you something about the history. It can tell you, is it sort of sandy, soft sediment material that breaks apart easily, that might tell you how it was formed? Or is it something that's been under huge amounts of pressure and then has been brought up to the surface later? Is it a igneous rock, which is the ones that come out of volcanoes? And so this solidifies and often goes very hard. So it really depends what it's made of, what processes it's been through, and how hard you hit it with a hammer, I suppose. Yeah. Any other questions?
When Mars is at is it weak or is it?
Can you repeat that for us so we can't quite catch it?
Mars's atmosphere, is it thin or thick?
Great question. Really good question. So it's very thin. It's about 1% the density of the atmosphere on Earth. So you sometimes see in movies, like in the movie The Martian, they show like a big storm and it's like blowing the spaceship around and people are falling over. In reality, this wouldn't happen just because the winds are fast, very fast, but the atmosphere is very thin. So it's not strong enough to knock big metal objects over like that. But it does, as Divya explained, it does pick up those very small, fine dust particles. And because the gravity is lower, it can bring them higher into the atmosphere. So we see dust devils, like little sort of spinny, dusty tornadoes that on Earth would only ever reach a few hundred meters in height, but they can reach several kilometers in height on Mars because this thin atmosphere with these fine particles and the low gravity means they can go up really high. So yeah, there is an atmosphere. It's mostly carbon dioxide, but it's extremely. Any more questions?
So,
Big voice, Nana.
as you were talking about what's going to people going to Mars, could scientists make this sort of genetic change to humans so that we could breathe on Mars if ever Earth was in danger? Like a big.
That's a big question, huh? Well, I guess we're all making genetic changes all the time, right? So that's evolution. When we see how generations adapt to their environment and certain animals and species and people, we have changes over time. But this is over very long time scales. to evolve something like being able to breathe a different atmosphere would take probably hundreds of thousands or millions of years. But if we did this using science, genetics, I mean, that's got its whole set of ethical questions, as you were talking about earlier.
But there was so there was actually a launch, I believe, yesterday to the International Space Station with a new experiment. And it's actually a certain type of protein that humans have that actually protects us from radiation. So we actually get a lot of radiation on Earth. Nothing like what we would get on Mars or the Moon, because we have lots of protection from the atmosphere and also our magnetic field around Earth. But we still have proteins in our bodies to protect our cells from breaking down. So they've actually synthesized some of these proteins, and they're sending them up to the International Space Station, where there's virtually no gravity. So we can actually put these proteins together in sort of crystals that we can't achieve on Earth, to actually see if it makes them stronger, if it changes how the radiation protection works. And then they'll send them back down to Earth for analysis. And so this is something that they might be able to implement in astronauts to protect them from radiation. So we're sort of thinking along those lines, maybe not genetically, but perhaps in like the proteins in our cells, to at least protect us from radiation. Whether that would work on Mars, I don't know, but they're thinking about it for astronauts just in Earth's orbit.
Yeah, and so there's a lot of legislation and ethics that needs to be involved whenever you're going to like experiment on people or animals. And so these are big questions. And I think that it will probably be easier to use technology to do things like give us breathing apparatus, and even to build big infrastructure like big greenhouses that have got oxygen in them that we can breathe. And then there's also the whole science of terraforming. Like this is something that is kind of a science fiction concept, and you can actually change the environment where you go and make the atmosphere different and change the whole weather system there. And maybe that will happen in the future, but that's something that's way off. So I think this combination of things, of seeing if there's different medicines or treatments we can give people that give them benefits for these environments, as we do all the time now. We give people inoculations if they're going to go somewhere where the environment is maybe difficult, and we give people protective clothing to protect them. We have sunscreen to protect us when we go out in the sun. And so it's just an extension of all these different methods of protecting us in different ways. But I think it's obviously part of the future. We're already seeing like gene therapy and stuff to help people with various different things on Earth. So it will all come together. And that's why space science is interesting as well. It's not just about rocket ships and landers. It has a whole host of things to do with human health and medicine that we're finding out about being in space that we didn't know about until people lived in space for months at a time. So I know that there's special exercises and stuff you have to do when you're on the space station to make sure your muscles are okay, because you're in low gravity and eventually your muscles will get weak. And this has lots of implications for human health as well. So we learn a lot about that sort of stuff. I think we've got time for one more question.
We're going to have to go back. We're going to have to go home soon, Jackie.
No!
So, we've got 5 minutes till home time. So,
okay, then.
So we're going to say our farewell. So what do we say to Jackie and her colleague?
Thank you.
Thank you so much. We really appreciate your questions.
All right. Okay, we'll see you later. Right, children, off you go.
See you later. Bye.